Good afternoon. I believe this will be one of the last two videos for all of AP Calculus. I figured it's time to go ahead and get these volumes taken care of. Volumes disk method, but this is also going to include the washer method. But we'll just start with disk. If I have the equation y equals x squared, and let's just say, or the area bounded by y equals x squared, x equals 0, or the y-axis, and y equals 0, or the x-axis, and let's go up to y equals 4. 1, 2, 3, 4. 2 squared is 4, so 1 squared is 1. So if we're just looking at this little part of the parabola, well, we probably didn't even need y equals 0, did we? Y equals 4, x equals 0 will clearly show us as this region. So if I'm taking that region, I'm finding the volume. If I rotate that region, about the y-axis. So it would fill in this little area. Rotating that region about the y-axis gives us this solid, almost like a bullet tip. It's kind of not quite pointed, but if it's completely filled in, that's kind of what it looks like. And so, just like we did with areas, we formed little representative rectangles. Well, if I took that representative rectangle and rotated around, it would become a little tiny cylinder. And a cylinder, or the volume of a cylinder, pi r squared h, is what the disk method is based on. We're going to take, remember, summing up all those individual disks, the limit as delta, in this case delta y, approaches 0, we are going to turn it into a definite integral. I feel like that's fuzzy, or it might just be my eyesight that's fuzzy. There we go. All right, so I did start off with a little bit weird one, but if I'm thinking of that little bitty slice, that cylinder that I pulled out here, I need a radius and I need a height. And the height I actually just showed is a dy. It's like a change in y value. So that goes in for the h. The radius is an x value. I can't take an integral, and I can pull that pi on the outside. I can't take an integral with a x and a y mixed up. So I need to figure out what is x squared. Well, x squared is equal to y. That was beautiful. I also need to come up with the limits of integration. And because if you remember from the area problems, the area from here to here, if we're dealing with dy's, would go from y equals 0 to y equals 4. Same thing here, 0 to 4. So this turns out to just be a very easy integral. The integral of y is just y squared over 2, 0 to 4. Plug in the top first. 4 squared is 16 over 2 would be 8. Minus 0. That area, volume, is 8 pi. So, disk method, the reason it's called a disk is because when we take those little slices out, they look like little bitty, teeny tiny disks. And it is filled in all the way through the axis of rotation. We can even take that same area from y equals x squared. Now I will include that y equals 0, and let's say x equals 2. We're going to take the region bounded by these values. 1, 2, 3, 4. 1, 1, 2, 4. Only in this case, we've got the horizontal line y equals 0, vertical line y equals 2. So even though we're using the same equation, we have a, oh great, it's not even on the screen. I do this at school too. It's awesome. Anyway, so I have a new area just because we're using a different set of equations to bound it. So that little area is going to be now rotated about or revolved about the x-axis. So if I rotate it around, now it's a weird looking thing. I always call these kind of like tornadoes, because if we rotate them, or a funnel, kind of looks like a funnel. The only issue is that it's a solid area, because that area, or it's a solid volume, that area is completely to the axis of rotation. But again, take out this little bitty slice here, and it's a vertical slice where, again, based on that pi r squared h, the volume of a cylinder, the h is just going to be dx. Now the radius goes from the axis of rotation out to the point on the original curve. Now some people will say, oh, that's about 1.25, Ms. Washington. No, that is a changing value depending on where we put our slice. And so it is the changing y value. Y is the radius squared. Pull that pi on the outside. But again, the issue is we can't integrate y's and x's mixed. So if y is x squared, then y squared would be x to the fourth. And again, we are integrating with respect to x. And so instead of going 0 to 4 like the last example, this one, the x values go from 0 to 2. And then, again, this would be a nice, easy problem for a non-calculator, because it's so easy to integrate. Integral of x to the fourth is x to the fifth over 5. 0 to 2. Plug in your 2. Of course, we could free response it. Just go 2 to the fifth over 5. Minus 0. Box it. Stick a fork in it. You're done. 2 to the fifth, though, is 32. Not over 4. Over 5. So, either of those answers is perfectly fine. That's the gist of the disk method. I'll do one more example. What if we have the equation y equals 4 minus x squared? And we're going to 1, 2, 3, 4, that y-intercept. And remember, it's just a parabola opening down, and it would hit the x-axis at 2. So maybe they would say the region bounded by this equation, the x-axis and the y-axis, or x equals 0, y equals 0. That area rotated about the x-axis. 1, 2, 3, 4. Rotate that one. And it is a dx with the radius just being from the x-axis up to here is just the y value again. So based on the pi r squared h, we're looking at y squared dx. But again, y is 4 minus x squared, so that is going to be squared dx. Sum up all those little slices, x's go from 0 to 2. Now this one you might think, can I use substitution or blobbage or whatever, and I'd say no, because there's no x out here. So you are going to have to FOIL that thing out. So now we can integrate that. 16x minus 8x cubed over 3 plus x to the 5th over 5. Obviously, since I write super fast, y'all can pause this to catch up or whatever you need to do. 16 times 2, 32, minus 8 times 8, 64 thirds. 2 to the 5th is 32 fifths, minus a bunch of zeros. Get common denominators. 32 times 15, 10, 2, 3, 480. So that's 480 over 15. 5 times 4 is 20, 32, plus 96 over 15. 480 plus 96 is 576, minus 320 would be 256 pi over 15. Let's do a little check on the calculator just to make sure. Many times these areas and volumes problems will be on the calculator page. If it's an AP, if it's a normal AP exam, who knows what's going to happen. Let's go ahead and do Math 9. 0 to 2, 4 minus x squared. Oh, phooey. Math 9. 0 to 2 of 4 minus x squared. Oh, it's still in my polar. It's okay. As long as you're using the same variable, it doesn't matter. Alright, 17.06. If we math, enter. 256 over 15. Throw in the pi at the end. We got it right. Alright. So, there's our disk method. Let me throw in one more example. What if I have y equals, I'll go back to my easy one, y equals x squared, y equals 0, and x equals 2. But we're going to rotate it about that line x equals 2. Turns out this one is also a washer method. We've got our nice easy parabola. Y equals 0, x equals 2. So this is our area. But if we're going to rotate it about the line x equals 2, see, then we're going to, our part that shows up when we rotate it is going to be on the other side like that, right? Oh, goodness. Terrible. Terrible, terrible drawing. But understand, is this idea still kind of like a funnel? But the issue is that the radius, this is where This is where you have to fully embrace how the plan is the same as long as this area is filled in all the way to that axis of rotation. It is pi r squared h, period. That's what it's based on. The issue is we have to figure out what in the world that radius is. Pretty easy to tell. The height is a change in y value, so it's a dy. The radius is a little bit different, because on any of these random points that we draw our slice, the representative slice, it has two values. The distance from here to here is the x value. Is the y value. The distance from here to here is the x value. So, if I'm looking for the radius that's from here back to this point, then what I need to do, and honestly, as I approach these volume problems, especially as I get into the washer method, I'm just going to label my height is dy. My radius is going to be 2 minus the x value, isn't it? From here to here, all the way up and down, that whole distance is 2. If this is a changing x value, then the radius will just be 2 minus x. Well, I'm not going to say 2 minus x quantity squared, because that's mixing x's and y's, correct? So, what I need to do is do a little substitution. If y equals x squared, then x equals the square root of y would be sufficient. So I'm going to say 2 minus the square root of y. It's sufficient because I'm only dealing with the positive quadrant, so we don't have to deal with plus minus. But so that r is squared dy, and the y values, oops, pi on the outside, the y values went from that 0 here to the 4. So there's nuances in every single example, every single problem. You know, you may be using an x value as a limit of integration like we did in the one up there, or you may be using a y value if you're integrating with respect to y. So just be careful. The other issue area is determining those radiuses or radii. Again, hopefully this would be a calculator problem, but we could FOIL it out. 4 minus 4 square root of y, or y to the 1/2. Square root of y times square root of y is just plain y. Integrate 4y minus, that's going to be y to the 3/2. 2/3 would make it 8/3 plus y squared over 2. 0, 2, 4. Gosh, that doesn't even look like a 4. And plug and chug. I'm going to come over here. 4 times 4 minus 8/3 times 4 to the 3/2 plus 4 squared over 2. Plugging in 0 gives me all zeros. There's that free response answer. Obviously, 4 times 4 is 16. The square root of 4 is 2. 2 cubed is 8. Times 8 would be 64. 16 over 2 is 8. So it looks like it's 24 minus 64/3. What's 24 times 3? 72. So 72/3 minus 64/3 is going to give me 8/3. Multiple choice answer, free response. And if I haven't said it again, I think this AP exam this year is going to Again, go all free response. They're going to get you to submit it, you know, in these time frame, these parameters, and interesting. But, and they might even just let you do it, the work on paper, take a picture, I believe, and submit it. Anyway, so I hope that gives you a really good, clear view of the disc method. We also have washer method. So I guess I'll just keep adding on here. Washer method. I think once you embrace the disc, washer's not that far behind. But a washer method, if you think of a little washer, it looks like a little cylinder, but it has a hole in it, right? So if we were trying to find the volume of that washer, we have a couple ways to do it. Typically, I will call that the big R, the big radius. I'll call this one the little radius, right? So we have a choice of doing the pi big R squared times h minus the little empty space, right? Pi little r squared h. But if you factor out the pi and the h, then this is kind of what's left. So pi times big R squared minus little r squared h. This is the washer method for finding volumes. So that's going to be if there is a break between your graph and the axis of rotation. So let's go to that. I was going to go to my y equals x squared, but let's go 4 minus x squared. That's this area. It is still just a parabola opening down. Hits the x-axis at 2. So what if I took that region, the area bounded by x equals 0 and y equals 0, also the x-axis and the y-axis, that region. But let's take that one and let's rotate it about the line x equals 2. So if we do that rotation, we have a really kind of strange looking figure with this empty space in the middle. But if you do take out that little slice, and if I looked at it carefully, it would look a whole lot like that washer with the filled in space and then an empty space in the middle. So that's how we know if our figure does not butt up against the axis of rotation, we will use the washer method. So again, I told you I usually will come over here and I'll list my big R, little r, and h. The h is a clear dy. It's the change in y values, right? The big radius goes from the axis of rotation out to the outermost point, and no matter where I drew that little slice, that big R is a solid too. And that's nice. The little r is going to be a changing value. Remember, here to here is our x value, right? And if there to there is 2, I'm going to say the little r is 2 minus the x value. Well, this was not a beautiful one to start with. But if I said x squared is going to equal what? 4 minus y. And then x would be the square root of 4 minus y. Again, positive quadrant, so we're okay. So the big R is 2 squared, minus 2 minus that x value. What did I say, x? It's a y. dy. Pi on the outside. And my y values clearly go from 0 to 4. I'm going to say because of this right there, I can't imagine them making this problem be on a non-calculator because of the sheer amount of time it would take to FOIL all that out. So I'm going to say plug and chug in the calculator. This, in fact, many times they might just say set up but do not evaluate. So set up but do not evaluate, done. So let's just go pi, math 9, 0 to 4, 2 squared is 4, minus 2 minus square root of 4 minus, well, it's theta in this case, quantity squared, d theta. .888 would be our approximate value. Just to prove to you that if we're not in our polar form, because I've been using this calculator for BC, I'm going to go back and change all these to x's. Same thing, right? Gives you the same answer. So, hopefully we're good on that one. That one was a doozy to start out with. Might have been better to rotate that thing. Y equals 4 minus x squared. X equals 0, y equals 0. How about if we rotated it about the line y equals -2? Same exact area. 1, 2, 3, 4. 1, 2. Parabola. That's the region. But if we go down here, y equals 1, 2, 3, 4. -1, -2. Would you be willing to put it, to keep it warm for me? I've got about 10 more minutes probably. Keep the toaster oven. So if I take this and rotate it down there, it becomes this really big, quite ugly, 1, 2, 3, 4. Super big, ugly volume with a big wide open area in the middle. I'm a terrible illustrator. I hope you're getting the idea behind it. That all that is an open space. Like this is filled in. Once you rotate that around, this part is filled in. Wide open space. Big old huge washer method. Big radius, little radius, height. That height is a dx. Now, the distance from here to here is the y value, right? But we need the big radius to go from, is it 2?
We got a meeting at 2.
From down -2 up to there. So I'm going to say I need 2 units plus the y value, 4 minus x squared. The little radius is a solid 2. I'm getting ready to have a meeting, an online meeting, so I've got to finish this problem, and I'll post it later. 4 plus 2 is 6, minus x squared. Big R squared minus little r squared dx. Plug and chug in the calculator or FOIL it out. Not sure which would be quicker. Let's go ahead and do math 9, 0 to 2, 6 minus x squared, quantity squared, minus 4 dx. Oh, that was a nice even number. So if we had done it by hand, we would have gotten 192 over 5 with the pi. 192 pi over 5. I will come back and finish up and do another little washer maybe or two, and I'll finish with the cross-sectional volumes. Good luck.